can catabolize many things, lipids, nucleic acids, starches, whatever. Many different possible things funnel down to a few simple end products. It acts like a funnel. And people often break this down. There's 3 stages of catabolism that are pretty obvious. The first one is just to hydrolyze the macromolecules. So in your liver, if you've got some glycogen stored, and you start being really physically active and your blood glucose levels drop, that liver is going to break down the starch, right, to free sugars. So that's stage 1, breaking down a macromolecule, breaking down a protein to its amino acids, or a complex carbohydrate to the free sugars. You're just getting to the level of building blocks. We call that stage 1. When you start picking apart the building blocks, the sugars and the amino acids, they funnel to not just acetyl-CoA. That's the prototypical one. There's a couple other things that would go to, but there's a core handful of a small number of building blocks. We'll just say acetyl-CoA for simplicity, for our purposes in this class, to core metabolic intermediates. And in the final stage, that acetyl-CoA gets fully oxidized to CO2. So it doesn't matter if you're starting with a lipid, a carbohydrate, a nucleic acid. If you do total oxidation on it, total catabolism on it, you're going to end up here at CO2 in the 3rd stage. And it all funnels through acetyl-CoA. So polymers in stage 1 get converted to these monomers. In stage 2, you're going to break all of these things down. So it doesn't matter if you're starting with glucose or palmitic acid, you're going to go to acetyl-CoA in this funnel. And then that feeds into the Krebs cycle and goes to CO2. You typically don't get any energy out of stage 1, just hydrolyzing these complex carbohydrates and proteins down to the monomers. You don't squeeze any ATP out of it. The process is downhill, but not big enough drop to harvest any energy. It's in stage 2 and 3 where you start to squeeze out some energies in the form of ATP. Okay, so catabolic pathways converge on a few common intermediates like acetyl-CoA. Feeds into the Krebs cycle, gets converted to CO2. The biosynthetic pathways are anabolic pathways in the reverse. It's like an inverted funnel. We start with a few simple precursors like acetyl-CoA, and it opens up into these branching pathways. You can send it towards cholesterol, or phospholipids, or whatever.
With rubber?
Yeah.
So what is
Biochemistry is